Alright, part 3, our last way of solving systems of equations is, you might hear it called elimination. Our book likes to use addition, whichever way, elimination or addition, it means the same thing. So our goal in each of these is going to be pretty simple, relatively simple. We're just trying to eliminate one of our variables. And what we're going to do is we're going to look at this system kind of as a whole. We're going to end up adding the two equations together. Okay, and so if we want to add our equations together, we add our x's, we add our y's, we add our numbers on the right side. We want to add all those together, but we want to do it in such a way that one set of variables cancel out. So we're starting off easy here. This is already set up for us to actually be able to do that, because look right here. If I do 3x minus 3x, if I add 3x and a negative 3x together, I get 0, which means that those eliminate. Okay, it gets rid of them. Now we continue adding down. Negative 5y plus 9y, which is 4y, 14 minus 6, or 14 plus a negative 6, whichever way you want to think of it, is 8. We can divide by 4, and now 8 divided by 4 gives us 2. That's what y equals. We plug it back into whichever equation up here we want to. It doesn't matter which one. They're both probably going to be the same amount of work. Okay, but we put the value for y in on one of them, and then we solve for x. So here we have to do 5 times 2, which is 10. We have to add 10 to both sides. So 3x equals 24, and then divide by 3. So x equals 8. So that gives us 8 comma 2, or x comma y, as our answer. Now that one was pretty easy. We were already set up to eliminate. Now we're going to look at progressively more difficult ones, that the difficulty lies in figuring out what to do to our equations so that when we add them together, we get rid of a variable. So let's look at the equations we have starting off here right now. Look at your y's. Both of those y values are negative 6. If we add those together, they don't cancel out. But if I were to change the sign on one of those, then one of them would be a positive 6y, and it would cancel out. So that's exactly what we're going to do. We're going to multiply one of our equations by a negative 1, so that we can change the signs. And it doesn't matter which one we change. I just picked the top one because that's the one I picked. No reason. So whenever we do this, we have to distribute the negative 1. Everything in our equation has to get multiplied by negative 1, not just what we're trying to change. So now I'm ready to add my equations together. Negative 8x plus negative 2x is negative 10x. Our y's cancel out. 10 plus a negative 20 is negative 10. Let's just finish solving that by dividing by negative 10. Negative 10 divided by negative 10 is 1. That's our x value for our answer. Now, when we go to plug this back in, we can put it into any of these equations we have. Okay, it doesn't matter which one. None of these would be easier than any other. You can always pick the first one if you want to. You can always try to pick the one with smallest numbers to make your mental math a little easier, but every single one of the equations will give us the same value. So 2 times 1 would be 2. So subtract the 2 over, we get negative 6y equals negative 18. Then we want to divide by negative 6 on both sides and get y equals 3. We want to write our answer as a point, 1 comma 3. So there we go. Next one. Example 3. Okay, now in this case, okay, we've had a case where all we had to do is add them together. We had a case where we just had to multiply one of them by negative 1. On this one, if you look, on our x's we have 2 different numbers. On our y's we have 2 different numbers. Okay, So what we're going to end up having to do is we're going to have to multiply one of our equations by a number that we can hopefully get it to match the other equation. So what I look at is right here. Really, we could use either one, but right here we want opposite signs so that when we add them together they'll cancel out. I have opposite signs, and I have 4y and negative 1y. So if I multiply the second equation by a 4, then I will get something that will cancel out. So that's what we're going to do. We're going to do negative 4x minus 4y equals 16. And then we're done for now with that equation. We could come back and use it later if we want to. But the two equations we're going to add together are these two. So if I add those together, I have negative 7x minus 4x, which is negative 11x. I have 4y minus 4y, which cancels out. Negative 16 plus 16, which also cancels out, but gives us 0, because that's the only thing on the right side. Don't be tempted to say this is like no solution. It's okay for that to equal 0. We divide by negative 11. 0 divided by anything is 0, so x is 0. Plug that back into any of the three equations we have. It doesn't matter which one we plug it into. We could even plug it into the second one that we had marked out. Just pick one and plug it in. So I picked the first one. 7 times 0 is 0. So that's going to go away, and all we have to do is divide by 4. So y equals negative 4, which means our answer is 0, comma, negative 4. Alright, we're still getting a little more difficult here. Okay, because now, on this last one, we were able to multiply one equation and get something to cancel out, but on this one, there's nothing I can multiply 4 by to get a 6. Well, I mean, there's a fraction, but there's no whole number that I can multiply it by to get 6. And there's no whole number that I can multiply 5 by to get 6. Okay, so what we're going to have to do is we're going to end up having to multiply both equations by something. So what we need to do is figure out a number that we can get both of the values in front of either x or y to equal. So I'm going to pick the x's. I'm going to say I want those to have the same value in front. So one way you can do that is you can always just flip-flop. And what that means is we can times the first one by 6. We can times the second one by 4. We flip-flops the numbers. If we multiply 6 times 4, we get 24. So we'll end up with the same thing in front of x on both of them, but one's positive and one's negative, which is what we want. The other way is it's kind of like finding common denominators, or a least common multiple. Like, what is the smallest thing I can get that 4 and 6 both divide into? Well, we could get 12. Okay, you can multiply the first equation by 3, the second one by 2, and get 12. Okay, but let's go and use 6 and 4. And we're going to distribute into our equations and come up with two new equations so that we can eliminate. So 24x minus 30y equals 6, and then negative 24x plus 24y equals 0. And we could have done the same thing with our y's. We could have flip-flopped on our y's, multiplied the first equation by 6 and the second equation by 5, and we would have gotten 30 in front of y, and that would have worked. I seem to have an issue here that my thing's okay. But we went with the x's, so we've got it where we can cross them out. Negative 30y plus 24y is negative 6y. 6 plus 0 is 6. Divide on both sides, and we get y equals negative 1. Now let's go back and plug that back in. We can plug this in to any of these four formulas that we have, any of these four equations, and it doesn't matter which one we pick. I like to always go back to one of my original equations where I end up with smaller numbers. Okay, just because I like to do mental math instead of relying on my calculator, and so it's easier to do mental math with smaller numbers. I want to put, oh no, that was right. I want to put -1 in for y. So 4x plus 5 equals 1. I subtract 5, get 4x equals -4, divide by 4, and x equals -1. Let me try that again. It's terrible. X equals -1. So my point is -1 comma -1. Okay, these last two are going to be us looking at our special cases. So if I look at this, I'm trying to eliminate. I can see, okay, I could take this 6 and I can turn it into 12 by multiplying it by 2. But they have the same sign, they're both positive, so I wouldn't just want to multiply by a positive 2, I'd want to multiply by a -2 on the second equation. And so what's going to happen when I do that is I'm going to end up with positive 2x minus 12y equals 22. And so we stop paying attention to that equation for now, and we look at -2x plus 2x cancels, 12y minus 12y cancels. That's everything on the left side, so 0 equals -27 plus 22, which is -5. This is going to have the same rules as we had with substitution. If it's 0 equals -5, that's not a true statement, so this is no solution. Our other case that we're going to look at, okay, I want to figure out a way to multiply the first equation by something to get the second one, since the first one has smaller numbers. Well, I can realize hopefully that to get 2 to be 6, I multiply by 3, and I need to multiply by a negative so that I have the opposite sign. So -3 times 2x is -6x, -3 times 2y is -6y, -3 times -2 is 6. When I add these together, everything cancels. That leaves me with 0 equals 0, which is true, so that answer is infinitely many solutions. Oops, that looks my bad. You get the point. Infinitely many solutions.